This is the we'll discuss about how to solve the elliptic circuit, which has the coupled inductor. So in the most convenient way to solve the elliptic circuit with coupled inductor is mesh equation. So we discuss about mesh equation in the coupled inductor. So we have a circuit, simple circuit here. This coupled inductor here, and one impedance in here. When is G2 and define, and then this is the mutual. So define, this is M, this is L1 and L2, and you define this is V1T, and define the current direction is I1T, and you define the direction of current is I to T, and define voltage is V2T here. And to solve this circuit, we can transform this as a phasor. So we can do this with phasor. Like that. Then you can replace the variables and define this is a V1, this is a V2 in phasor. It's I1 and this I2, and this is J omega M, this is a J omega L1, J omega L2. So in this time, we can make a mesh here. This is mesh 1, this is mesh 2. So we make a first mesh 1. Then at first we met minus V1 and plus we met this voltage here. What is the voltage of that? That is J omega L1 I1, and because of mutuals we have another terms J omega M I2, but need to know the direction of that. I2 is going out from the dot, so it's going into the no dot. Therefore this voltage is positive in no dot here, but this direction is inverse, so we make minus. Therefore it will be 0. So we write here is V1 is J omega L1 I1 minus J omega M I2. Then how about the mesh 2? Mesh 2. We met minus V2 plus G2 I2 is 0. So what is a V2? What is a V2? V2 here is because the direction is going out from the positive value is I2, so minus J omega L2 I2, and J omega M I1. This is a coupled values, but it's going into the dot direction, so this is dot, this is a plus here. So replace with here minus J omega L2 I2 plus J omega M I1 plus G2 I2 is 0. Therefore, we make a simplify minus J omega M I1 plus J omega L2 plus G2 I2 is 0. So we have two equations, this one and this one. And from that, you can get the I2 here. From here, I1 is V1 plus J omega M I2 divided by J omega L1. And insert the value over here. Then minus J omega M J omega L1 V1 plus J omega M I2 plus J omega L2 plus G2 I2 equal 0. Now from here, I2 is J omega M J omega square L1 L2 minus M square plus J omega L1 G2 V1. So if K is 1, that means M is L1 L2. Then I will be simply calculated J omega L1 G2 J omega M V1 will be L1 L2 V1. And therefore, V2 equal to G2 I2. That will be G2, this is I2, 1 over G2, L1, L2, V1 will be L1, L2, V1. And here you remember that L1 was C1 N1 squared, L2 is C1 C2 N2 squared. But in this case, K is 1, so the C1 is C1 and C2 is the same things because all component is coupled. Therefore, V2 is N1 N2 square root V1. V2 is N1 N2 V1. So from that, V1 V2 is N1 N2. So let N1 N2 over N1 define this N is a term ratio. Then V2 is N V1. So that means we already learned about the transformer that is in your high school. So it'll be quite simple. This is the transform voltage is transferred with the turn ratio. So that's it. That means the ideal transformer means perfectly coupled. So coupling coefficient is 1. Anyway, we can solve the circuit like that. This is the first example of coupled inductor. Example 11, 9, and 1. Find the V2T. The circuit is very simple. this is the AC socket here. It is 5 cosine 40 plus 45 degree, and the resistor here, and coupled inductor. And resistor is load. This is 12 ohm, and this is 4 Henry, this is a 3 Henry, and mutual is 2 Henry, and this is 8 ohm. This is a problem. And the defined, this voltage is V1, and this voltage is V2. So to solve this, I will define the current direction. I define the current is, this is I1T, and also I define the current in this direction, I2T here. So we can redraw this circuit with a pager. How can do that? I can redraw this. The pager. This is omega is 4, and this is 5 and 45 degree. This is resistor, so 8. Resistor 12. Then you define this is a 4 Henry, so therefore J16. And this is 3 Henry, so J12. This is 2 Henry, J8. And you define the voltage here. This is a V1, this is a V2. And define the page current is I1, and define I2. So to get here, at first we make 2 equations from the coupled inductor. And what is that? V1 is J16 and I1. Because this is positive, it's going into the positive, J16, I1. And another term is I2 and coupled, J8, I2. We need to figure out the direction of that. Here is the, I'm missing the point of that. This is that here and here. I2 is going into that. So the product of that is that this is positive, but this is positive, so this is positive. The same way, V2 has 2 terms, I2 and J12. J12, I2, and I1 and mutual. I1, J mutual. You know, the positive, and this is the same direction of I2, so that will be positive. And I2 is going into that. So that direction is positive, but I2 defined is positive. So this is positive. Okay, that's it. Then from here, so we can make mesh equations. So in the first mesh, we have minus 45 degree plus 8I1 plus V1 is 0, right? And secondary in this direction here is minus V2 minus 12I2 is 0, because we make mesh in this manner. It's minus V2, and because we're going into the here, this is a positive minus, so we make minus, we met minus in this loop, so this is minus. So after that, we insert this term and this term in here and here. So 45 degree is 8I1 plus J16I1 plus J8I2. And this term is V2 here is J8I1 plus J12I2. It will be minus 12I2. So we can simplify this here. Is J8I1 plus 12 1 plus J(I2) is 0. Therefore, I1 is J8, 12, 1 plus J(I2). That will be 3/2 minus 1 plus J(I2). Then apply I1 is there. Then that value is 5 plus 5/2. J is 8. I1 is that values plus J16 and 3/2 minus and plus J plus J8 I2. So there will be from here, this is 8, 4 is 12, 1 plus J16 minus 1 plus J plus J8. I'm sorry, it's wrong. It's not 16. It's actually this is 1 and 2. So 12 minus 1 plus J minus J2 and minus 2 plus J8 I2 and minus 36 minus J4 I2. So from here I2 is 545 degree and minus 36 minus J4 will be 0.14 minus 104. Then result. So from here we can calculate the V2. V2 is here, you know that the V2 is that values minus 12 I2. Therefore 66 degree. From here V to T can be written as 4T plus 38 point. This manner. We can calculate the coupled inductor, the voltage is very simple in this manner. So only different thing is we have a coupled inductor, then you need to make an equation based on the coupled inductor equation in this manner. Then you apply this equation to the circuit, and everything is the same thing we discussed in previous. So we have another example. 11, 9, and 2. To register and inductor and another inductor here. Define this is a VOT. This is 4 heli. This is 5 heli. And two inductors couple each other. So this is 2 heli. This M is 2 heli. And this is that. And here is that. This is 5 ohm. This is a VST. And VST is and find the VO is a problem. Then what should we do? I mean, before discuss about that, what is that? I want to know what is that. I mean, that if the couple inducted in this manner, this form is familiar with us, and this is that here, and this is that here. This is a 4 heli, this is a 5 heli, and mutual is 2. In that case, that terminal and that terminal is connect each other in this manner. Okay, and this is a V out. And that is connected to the dial here. Register 5 ohm and the source in this manner. This is a configuration of the circuit with a familiar form of the coupled inductor. You know that? So it is a little looks more complicated. So we can redraw this form is in this manner. But anyway, we don't care about that. We will solve this circuit with pager because this is AC circuit. All right. Because this is a VS. The VS is a VS. This is a register to 5. Because omega is 3, so this is a 4 heli. Therefore, J12. This is a J15, and the mutual is J6. Then this is a VO. Here we need to find out the voltage and current. So I want to define the voltage here. At first, I want to define the voltage in this manner. Define this is, I like to define the voltage plus minus V1. And this current is I1. I define this way. And I also define this way. This is a V2. And this current in this way is I2. That means I define this is a V1. Then this current is I1. And I define this is a V2. And define I2 in this manner. So from that, we can get our voltage equation is a V1. What is a V1? V1 has 2 terms. What is that? This terms and I and this terms. We have 2 terms. J12 I1 and J6 I2. You know, the I1 is going into the positive V1, so there will be positive, and I2 go to the non-zero, no dot. Therefore, this voltage is positive, is no dot here. The same thing, so this is positive. The same way, V2 has two terms. What is that? J15 and I2. And I1 and coupled J6 and I1. Because I2 going into the positive direction of V2, so this is a positive, and I1 go to the no dot here. So this term is positive in this term. But that is the same direction of V2, so this is a positive. So we get it. Then the remaining thing is the apply and the equations to solve this equation, this circuit. So I'd like to solve this mesh in this manner here. Therefore, minus Vs plus 5I1, and we met V1 plus V1, and we met plus V2, plus V2 is 0. So that's it. That's it. So, and we need to, this is open circuit. Therefore, I1 is the same with I2 because this is open circuit. So I1 is the same with I2. So we define this as I. Then Vs is 5I1, I1 is I, plus V1 plus V2. That's 5I plus V1 is this. J12I plus J6I. And plus V2 is this. J15I plus J6I. So it will be 5 plus J39I. So from here, we get that I is Vs divided by 5 plus J39. So Vs was Nepers 5.94 and 140 degree and 36, 39, 32 and 82. You can use a calculator. So 0.15, 57 and 31 degree. So this is I. So we calculate, we need to know the VO. V1 is same with the V2, and V2 is J12 in I, 21 in I. So 3.15, 147.31 degree. So from here, VGT is 3.15 cosine 3t plus 147.31 degree volt. There are example 11, 9, and 3, and that's the problem. Is only different thing is the dot positions. In 11 and 9 and 3, the position is dot is moved here. And this is the same problem. So the different thing is maybe this equation will be different because the dot is moved. Other positive the terminal. This is an ideal transformer. The ideal transformer is a model of a transformer with coupling coefficient equal to unity. I mean, K is 1. This is an ideal transformer. That's it. So I already showed you that is an ideal transformer. Actually, this is a couple inductor here. So we define this, and the turn number is N1 and N2. Mutual is impedance is GM. This is GL1, GL2, and you can define the voltage here. This is V1, and V2. Then make a current I1. This is I2. So here we get it. The V1 is GL1 I1 plus GMI2, and V2 is GL2 I2 plus GMI1. And here GL1 is J omega L1, GL2 is J omega L2, and Gm is J omega M. So if K is 1, that means M is L1, L2. So there will be J omega L1, L2 the same with GL1, GL2. Therefore, we can apply this in here. We apply this there. Therefore, V1 is GL1 I1 plus GL1 GL2 I2. In the same way, V2 is GL2 I2 plus GL1 GL2 I1. So from here, I2 is 1 over GL2 V2 minus root GL1 root GL2 I1. So apply I2 in here, then V1 is GL1 I1 plus root GL1 GL2 1 over GL2 V2 minus I1 here. Then the result is plus GL1 I1 minus GL1 I1. So when you make up the coupling into modelings, we assume that GL1 is kind of a C proportional to C1 N1 square, and GL2 is proportional to C2 N2 square. when your coupling coefficient K is 1, that means C1 and C2 is same. Because the old flux is coupled in the same coils, I mean the primary coil and secondary coil. So therefore, V1 is N2 N1 V2. From here, V1 V2 is N1 N2. And I1 is minus N1 N2 I2. So from here, you can calculate that V2T is N1 N2 V1T, and I1T is minus N1 N2 I2T. This is because you make a current direction of I2 in this manner. If you reverse the direction of I2, then this polarity will be changed. Actually, anyway, that is the ideal transformer. So if you make a direction is here, and this term means, this expression means ideal transformer. You need that here, and we define this is a V1T, and this is a V2T. Then we define the direction of current is I1T, and define this is I2T here. Then V2T is N1 and V1T, and I1T is minus N1 and 2 I2T. But if you defined in another way, this is an ideal transformer, and define this as that and that. If we define this is a V1T, and this is a V2T, and define the current is I1T and direction, this direction, I2T, then V2T is the same thing, N1 and 2. N1 and 2 is turn ratio. N1 and 2 is V1T, but I1T, 1T is in this manner. This is ideal transformer. So when you power, we calculate the power. P is V1T, I1T plus V2T and I2T. Therefore, this is a V1T and I1T is minus Ni2T plus V2T is NV1T and I2T. Therefore, that is a 0. That means the transformer is lossless system. Zero complex loss, zero average loss, and zero reactive loss. But this is in this case of the transformer is ideal. Ideal coupled inductor. That means the coupling coefficient is 1, then there are no loss. So here we want to know the impedance in the transformer. This is quite important here. If we have a voltage source, we have a ideal transformer. This is the impedance here. So before the ideal transformer, when you describe the coupled inductor, we need to define that values. We need, before the ideal transformer, we define the that self-inductance, self-inductance, mutual inductance, and in that positions. To make equation, the voltage equation using the coupled inductor, we need to know that there are three variables here. But if the transformer is ideals, then you don't need to know about that variables. We just only to know is a turn ratio and that position. That's it. So we don't need to about the mutual inductance, self-inductance. We only to know is the turn ratio and the that positions. So in the ideal transformer, you don't need to about the self-inductance and mutual inductance. In this case, we only to know is a turn number. That's it, and the polarity here. So we define this is a G2, and define this is V2, and we define this is I2, and define this is I1. This is a V1. So in this case, the V2 is N2 over N1 V1, and because direction is going into the ratio, mean that point, and the current is going out from the dot here. I1 is N1 N2 I2. So what is the impedance here for G2? And G2 is V2 divided by I2. So V2 was, and I2 is, and from here, I2 is reverse 1. And that is N1 and 2 square I1 V2. Then what's that? I'm sorry, it's wrong. This is not V2, this is V1. What's the meaning of this? This is here V1 and I1, there's some impedance. This is impedance. This is V1 divided by I1. So this is a G1. This is primary impedance. So this is N1 N2 square G1. What's the meaning of that? That means we have a transformer, ideal transformer here, and we have impedance is G2. This is N1 and N2. This is the same circuit with same source, Vs. This is G1. When G1 is N2 N1 square G2. It's the same things. So we call this is an impedance transformer. So this is, voltage is, we define the voltage ratio is, turn ratio. Voltage is transferred through the turn ratio, and current is transferred is the reverse of 1 over the turn ratio, and the impedance is transferred to the turn ratio square. It's a quite simple and very fun theory. So we can summarize the impedance in ideal transformer. So impedance transform, we have a circuit here, and a transformer here, this is impedance, this is G, and the turn ratio is N1 and N2, and this is the same circuit with same circuit, and we have equivalent impedance. That is, you can say the N is turn ratio. If defined like that, then TEQ is the same with Q G. Because this is the impedance transfer with the ideal transformer. This example, we have an example here. The 11, 10, and 1. We make a maximum power transfer. We have a circuit here, plus minus, and we have impedance RS. We have an ideal transformer here. And this is the load impedance. This is RL. And here is RS is fixed, and RL is fixed values. Then you need to find out is the turn number is 1 and N. Turn ratio N to transfer maximum power. To RL. So RS is, RS is 45 ohm, RL is 8 ohm. So to do that, through the maximum power transfer theory, when the circuit looks like that, and we have here, and we have another impedance here. This is 48, and this is R equivalent. The power is maximum when the series that impedance and that impedance are the same things. Therefore, now if the transfer the impedance RL to this direction REQ is the same thing, same values, then power is maximum to the transfer to the RL. So what is REQ? REQ is 1 over N squared RL. Therefore, 48 is RL was 8. Therefore, N is that values. So the secondary coil should be windings as compared to the primary coil 1 over the root 6. That is N values. We have another example. Example 11 and 10 and 2. So we have a circuit here. It looks simple. and then register in the ideal transformer. And register and inductance here, just like that. In here, so we want to know the V out. There is a problem. What is a V out? And Vs is 75.5 cosine 40 plus 26 degree volt. Then this is 3 ohm, this is 8 ohm, and this is 9 Henry. And this is the VOT. That's the question. So to get here, we need to make it more simple. How can do that? You define. I will redraw this in pager here. And here, then there is a 75.5, 26 degree, and define this quantity is I1. This is 8, and turn ratio is 3 and 2, and this is 3, and because omega is a 4, therefore there is 36. We have defined VO. This quantity is I2. Then to get the VO is exactly the same with the 36 and I2. So to get a VO, we want to get the I2. So that is the first. So to get the I2, and where is I2? Because of this is ideal transformer, I2 is 1 over n I1. So that's it. So I think I1 should be obtained at first. So to make a simplify these equations, so I will redraw this is a 1, okay, and this and the 1 8. This is I1, this is the VS. The equal transfer the impedance from the secondary winding through the ideal transformer. So GEQ is transformed value of that values. That impedance is 30 plus J36 is transferred to the 1 square, and N is no. It looks like that. So then result is 37.5 plus J81. So I1 can be calculated simply because I1 is then A plus GEQ and VS. Then VS was 75.5, 26 degree, and we're adding here 75.5 plus J81. So the calculated result is 0.68 minus 21.01 degree. So from that, we're adding here. So I2 is 1.02 minus 21.01 degree. Therefore, VO is J36. 36 is 36 and 90 degree, and 1.02 minus 21.01 degree. So then the result is 36.72 and 8.99 degree. Therefore, VOT is 36.72 cosine omega is 40 plus 9 degree. We can calculate simply with the impedance transfer. Another example 11 and 10 and 3. This is complex power case. In ideal transformer. There are no specific things. We can use a general solution, general approach to solve the problem, to solve the electric circuit. So we have a circuit here, and this one impedance here, and ideal transformer, and we have another impedance here. There's 1 and 5 turn ratios. This is a V1, the pager is V1, and define this is a V2, and this is dot and dot, and G2 is 1 to 5 plus J50, and define this is a I2, and define this is I1, this is G1. G1 is 4 plus J8. That's it. So we want to calculate the complex power. So from that, it's supplied by the source. You want to know the complex power from this. It's a very simple problem. We make a simple the circuit like that. You have a same source, but the impedance and one more impedance. It's very simple. This is a G1 and GEQ is values. So N is defined N2 over N1. So this is the 5. So then use the 5 point plus J2. So define this is I1. Now I1 is Vs divided by G1 plus GEQ. Vs was 120, 15. G1 is 4 plus J8. So it's 9 plus J10. So that will be 8.92 minus 1 degree. So from here, we need to know the power. The S supplied by the source, Vs by source is half Vs I1 conjugate. Then half Vs is 120 and 50 degree, and current is 8.92 conjugate is 33.01 degree. So there is a complex power provided by source. If you want to know the complex power consumed by G2, I mean S by G2, the same way is V, and that to that, this power is transferred to this power. Why? Because this is ideal. I mean, no lossless system in the ideal transformer. So we can transfer that is V1 and I1 conjugate. To calculate that, we need to know the V1. What is a V1? V1 is, this is a V1. So GEQ I1. GEQ is 5J2. I1 is that plus 92 minus 31 here. So that value is 48.08 minus 11.21 degree. So you can use it. Half V1 is 48.08 minus 11.21. And current conjugate is 8.92, 33.01 degree. So the result is 27.65, 21.81 degree. So there will be 202.07 plus J 80, 81, 86 VA. This is complex power received by G2. It's very simple. Only different thing is you need to transfer the impedance to make a simplify the electric circuit. In the case of circuit has the ideal transformer.